Hello, I'm Susan Nash, AAPG. Glad to be here for our Science and Technology Showcase. Our guest today is Geoffrey Thyne of Salinity, E-Sal, and he's here to talk a little bit about how he got interested in engineering salinity and the improvements in progress in reservoirs. So welcome, Jeff.
Hi, Susan. Thanks for having me today. It's a great
So,
opportunity.
Great to have you. And just as we get started, how did you get interested in basically oil and gas, and what is your background?
It's kind of funny. I actually got my undergraduate degrees in chemistry and biology, and then went to Texas A&M to become an oceanographer. And I got my master's in oceanography. And of course, there aren't many jobs for oceanographers. So I took a job with ARCO, Oil and Gas, in Plano, Texas, at their R&D facility. And I have to admit, quite honestly, at that point in my career, I only had one geology course. Later, I went back and got my Ph.D. in geology. But that's how I got started. And I really got started in enhanced oil recovery with CO2 gas. And so I ran a lot of those experiments. And that sort of grew into reservoir quality prediction and diagenesis. And so I spent 7 years there and really became engrossed in what I would call geochemistry, petroleum geochemistry, oil typing, all that sort of thing. And that got so interesting. But then 1984 happened, 85, and oil prices went in the dumper. And so this is very familiar to all of us right now. And so I went back to school, and I went to school, got my PhD in geology, working with a guy at University of Wyoming named Ron Surdam, and he was in reservoir quality prediction as well. And that was a very, very interesting, became fascinating to me. And I really stayed focused in reservoir quality, prediction, water chemistry, things like that, for the next 15, 20 years. And I had an academic career during that period of time, Cal State Bakersfield, the oil patch, Oklahoma West, as we used to say, and then Colorado School of Mines. And then finally came all the way back to University of Wyoming and worked for the Enhanced Oil Recovery Institute, kind of back to my roots, way back there at ARCO.
Oh, wow.
Yeah.
Wow, that's interesting. So what were your research interests when you were in the enhanced oil recovery?
Again, I'm laughing a little bit. I got hired by a guy at an AAPG regional meeting, Billings, Montana. Okay. Guy walked up to me. He was a professor there, so he knew me. And he said, Jeff, have you got any postdocs coming out of School of Mines? I have this project in carbon sequestration, of all things. And I said, well, tell me a little about it. And he told me what he needed. And I said, Jim Steitman, Randy Martinson's husband, I said, Jim, I don't think a postdoc could do that. And he said, well, what about you? And I said, Jim, I got a job, I got a wife. And he goes, I got a number. And and I made a phone call after he told me the number, and we moved to Wyoming. And so I was working in carbon sequestration. And
that's wonderful.
Yeah, and it's really interesting. And as you know, carbon sequestration and now CCUS utilization, combining it with EOR. And he walked up to me one day as my boss, and he said, what do you know about low salinity water flooding? And I said, I don't know anything about it. And he goes, good. You're going to now learn all about it, because the state, it's a state agency, we're considering recommending it to producers in Wyoming. And we need an independent verification that it works. And so that's how I got into wettability, because at the time I didn't know anything about it. Low salinity water flooding wasn't really seen as necessarily wettability alteration. And so I started into the project, and I absolutely proved with field cases, laboratory cases, and modeling it didn't work.
Oh my goodness.
Yeah, and so one of the people who had participated in the project from a Rocky Mountain Oilfield Testing Center up in Casper called me up, and she was back out in private now, and she said, why didn't it work? I thought it would work. And I said, I thought it would work, Vicki. I don't know. And so that's how it got started, really, is I sat there and I thought, why didn't this work? Because it had worked other places. It had worked for Shell in Syria, it had worked for BP on the North Slope. We had good field examples of it working, and yet it didn't work in a particular formation, the Minaloosa sandstone in Wyoming. And so sometimes figuring out why it doesn't work one place leads you to why it worked the other place.
Well, I really like the way that you're saying that, because right now, in this particular moment in the world and in industry, we're having to pivot. And many times that pivoting happens when we come up against a wall, and we have to ask ourselves, well, okay, why didn't it work, or what direction can I go to have this work? And that mindset, that positive mindset, I think is really valuable, and is something we all need to hear right now.
I couldn't agree more. The thing that really got me, well, first, the technical problem is always intriguing to people like us. And you think, how does this really work? But the other thing was, I've been through the industry a long time. And so I think most of us who have been around a while have seen the ups and downs.
Yes.
And I'd like to first say to everybody out there, remember, we've had these drops before, these valleys. If you look at a chart of oil prices for the last 70 years, you'll see the ups and downs. And the down times always turn to up times. And it's getting through. And I think a lot of people, especially the young people, need to hear that, because I remember, 1985, boy, everybody's getting laid off. What do I do? Am I going to stay in the industry, or am I going to move on and use my skills elsewhere?
Well, right. Yeah. And this time it's writ large, it's global.
Yep.
And we may not even know what the industry is that we'll be able to pivot into, and the relationship that it has with what we're doing, but we can make that, we can find it.
Well, yeah, exactly. And, we had this same thing 15 years ago, and then hydraulic fracturing came along.
Mm-hmm.
And it unlocked shale. And, that's been a glorious experiment, is the way I would put it. And I don't know if we're closing that chapter or not, but shale really was a response to the fact that the old conventional fields, what are there, 1,500 fields that produce 75% of the oil in the world, are declining, and we're not seeing big discoveries of new ones. And so shale was an exciting new chapter that was being opened. And I think the exciting thing for us at Engineered Salinity is the next chapter.
Right.
We see the next chapter as those huge conventional fields, those 1,500 big fields, and all the small fields, all the stripper wells out there that operate throughout the world, particularly in the US, leave behind at least 50% of the oil.
That's just amazing. Amazing.
It's unbelievable. We've pumped 1 trillion barrels, and that means there's between 1 and 2 trillion barrels left where we already know it is.
Wow.
And we already have the infrastructure in place. So Engineered Salinity was really an attempt to say, right back to my roots in enhanced oil recovery, we always heard, if it was just $15 a barrel more, we could do enhanced oil recovery, be it chemical, CO2, thermal, whatever it was. And yet somehow, even when it was $100 a barrel, we didn't do it. Well, maybe now it's time to actually do it. But you've got to be able to do it simply, and you've got to be able to do it in a cost-effective manner. You've still got to make money even at $25 or $30 a barrel. So that's what Engineered Salinity is really about, is a way to go back, get a significant portion of that oil that's still in the ground, and do it and make money at 25 to 30 a barrel.
Well, let's take a look at your slides.
All right, thank you. So this is fairly straightforward, I hope. Let's see, magic's supposed to happen here. There we go. So over here on the left-hand side,
it hasn't changed yet on my screen.
it's changed over here. So technical difficulties, kids, don't be discouraged.
You might need to start, you may need to start your slideshow.
Yeah, because I've got it here. Let's see. Gosh, it's always something, isn't it?
There we go. Okay.
Oh, good. Are we on the title slide now?
Okay, now we're on the title. Let's move. Let's see what.
All right, so I'm going to give it a shot to go to the next slide. Any hope?
No, whatever you did, you might have to
Let's see.
resume slideshow.
Yeah, I tried that. Slideshow, Zoom slideshow, add or remove buttons. No, boy. See, this is where the next generation will really.
Well, go back, go up to the top. Okay, there we go.
Oh,
Yay, got
okay,
it,
here
got
we go. Okay, good.
it. Good job.
So over on the left hand, so wettability. It's all about wettability, and I know there's still arguments about this in the literature, but the vast majority of people who work in this field have all come to the conclusion that salinity is related to wettability, and wettability controls your rel-perm curves. And so all the engineers out there can relate to this. You know, you get your data for your rel-perm curve, and you produce your whole field, and you spend your entire 30 or 40 years on that field with that rel-perm curve. And you never think about the fact that that's a snapshot in time. That as soon as we start pumping fluids in or taking fluids out and having other fluids come in to replace them, we start changing the wettability, and so we change our rel-perm curves. And so this idea that salinity and wettability are related is always out there in all the papers, and you know, everybody puts a sentence in and references somebody, but is it a tool? That's the question. Is it a tool for us today? And so over on the left, I've put some graphs, and this is some data from our laboratory. Salinity goes from high to low, from left to right on the x-axis, and wettability is there on the y-axis. And over on the right-hand side, you can see that the oil wet numbers are kind of in brown, the neutral wet numbers are in green, and the water wet numbers are in blue. And so this is exactly the same rock. This is the same brine. This is the same temperature. The only thing that's different is there's 3 different oils. And this is all from shale in the Permian. And what you see is you can sweep across salinity in the blue line, and there's really no effect. Wettability doesn't change with salinity. And yet with a different oil, the red or brown oil, you can see that as you make the salinity more fresh, lower the salinity, the wettability changes from fairly water wet, where all 3 start, to the edge of neutral wet. And then in the third case, you change salinity, and rapidly the wettability shifts until it's neutral wet, which is this value of 0. This is the Amott-Harvey scale. And then lowering salinity actually makes it move toward more oil wet. And so now, as an engineer, as a geologist, as a person running an oil field, I have a tool potentially that I can change wettability. And wettability changes that rel-perm curve. And now the question is, how do I manipulate this? I manipulate with salinity. Where's my target? What do I want to get to? And that's my next slide, I hope, here.
Yes, that looks great.
Oh,
That's so interesting.
Thank you. So the next slide is showing us there's a curve. There's what we call the happy phase. And over on the left-hand side, there's the happy phase with a lot of data. And so wettability is on the x-axis, and residual saturation, so this is after water flooding, is on the y-axis. And what it's really saying is that, surprisingly, to me anyway, I was always taught you want to be water wet, because then oil doesn't stick to the rock and it can move. But it turns out there's actually better recovery at neutral wettability. This kind of water and oil move equally well. That's what neutral wettability really means. And you can see, you can go from residual saturations of 35 or 40% all the way down to 5%. You know, that would be 95% recovery. Incredible. Just by changing wettability. But most reservoirs are not at neutral wettability. And so that's the whole idea behind E-Sal. One, we can look at how your reservoir reacts to salinity, and then we can decide, is there a particular salinity, whether it's in your drilling and fracking fluids or your water flood injection fluids, that are going to bring you close to neutral wettability. Now, as a geologist, when I saw this is engineering data, I was like, oh, that doesn't happen in the real world. If it did, I, as a geologist, should be able to find an example of this really happening. And there's no place where on water flood you get 80 or 90% recovery, right? I mean, we all know that.
Right, yeah.
But that's not true. So I went out and I looked in the DOE Tourist database, and there was one lone recovery factors of the graph, a bar chart. And there's this one lone guy out here at 80%. And I thought, oh, that's a mistake. I'll track that down. And I did. It turned out to be the East Texas oil field, the largest oil field in the continental US. And they have grown, yeah, and it's a woodbine sandstone play.
Stratigraphic, yeah.
Yeah, stratigraphic trap, nice sandstone, not like exceptional, but good sandstone, good
Right.
quality reservoir.
18% porosity, something like that.
Yep, they're down to 10 to 20 acre spacings over 60 or 70 years. Okay, fine.
Yeah.
And 80% recovery by re-injecting produced water. And I was like, what's going on? And then I found a reference where a fellow had talked about this in the late 80s, that they were near neutral wettability naturally.
Okay.
And so it's not just data from a lab, it's actual fields that if you are at neutral wettability, you can have exceptionally high recoveries. Compared to the world average is about 35% on water flood for recovery. And so I thought, wow, if we could take our existing stripper wells in Oklahoma and Texas and Louisiana,
right,
and drive them to 50, 60, 70% recovery, that would be energy independence for the US. It would be keep the mom and pops and the small companies and the big companies in business on these old conventional resources, and open another chapter.
Well, I like that, because the main thing is to keep the, to not plug, or at least not lose those wells.
Right.
Because when it's time to bring them back, at least be able to. Because, I mean, obviously what's going to happen in the next couple of years is that it's going to be a winner, the last man standing game, where we'll see a lot of consolidation, and then we'll have basically oligopoly in pricing. So the prices will go up, especially as the demand comes back, and then we'll start seeing headlines like, well, $200 oil, is that a possibility? Things like that, which it probably won't, because they're always wrong. But
well, we've heard this before, haven't we, Susan?
yes.
$150, $200 a barrel, because it's harder and harder to get.
Right.
And so that's always the rationale. And for us,
yeah, and even though there are a lot of countries that can produce, they're going to be desperately troubled in these upcoming months and years in terms of maintenance and infrastructure, et cetera. So I think we're in for a very weird time if we look at 18 months to 5 years.
I agree with you. That's been our analysis at the company. And so we're focusing on domestic, North American, including our Canadian partners. We're focused on, let's get this technology out there to these people. It's a lot like hydraulic fracturing. When it first happened, everybody was like, oh, you can't make this economic. And there were early cases that it wasn't. And, people can argue even today, is it economic or not? But we learned so much by putting it in the field. We refined this so much, and we feel the same with this technology. You get out there, you start doing it in the field. Sure, you're going to learn some things. Not everything's going to work like it did in the lab. But what's the payoff? So that's my last slide, because I think, this is all nice science, but hopefully there's another slide up now.
Oh, that's good. Yeah, I like that, because it really shows that the potential is there. And I just wanted to point out too that it's a very environmentally friendly solution compared to, say, refracking shale.
Yeah, we use no chemicals. So we constantly get this question. People come, our clients come, they talk to us and they go, okay, so what chemicals are you using? And it's like, we don't use chemicals. We just change salinity. Well, what ions are you using? You're using no. We're just changing the salinity. And it's unbelievable. So this is an actual case. And so people always say to me, unfortunately, a lot of our NDAs, we can't talk about our projects.
Right.
So I'm going to talk about another project. And this was a happy accident by ConocoPhillips.
Mm-hmm.
This is actually from the North Sea. This is Ekofisk field.
Okay.
So over on the left-hand side, what you see is our lab look at Ekofisk. We start out fairly oil wet. That's a minus 0.65. And as the salinity changes, it becomes neutral wet. And what happened in Ekofisk was they started the water flood. The projections were about 35% total recovery on water flood. And they ran out of makeup water. Well, it's an offshore field, so they started injecting seawater. And seawater lowered the salinity by a factor of about 2.5. And so that 2.5 is about where that little kick in the graph is. And so what we would project, we take that number, how much we shifted wettability, we put it over there on the happy face, and we can, say, oh, it's going to be this much less residual saturation. Residual saturation is going to go down about this much, according to the lab work. Now, the total, if you took it all the way, which is the green dot, it would change at 0.25 saturation units, so 25%, assuming you started at 100% saturation. Ekofisk actually started about 77% saturation, oil saturation. And the actual data, what they actually did was lower the salinity, like I said, about 2.5 times, not the full length of this thing. It shifts enough that you would project that you would get about 15% more production than if you hadn't.
Wow.
15% OIP, higher recovery, 15% higher recovery factor. And in fact, over there on the right-hand side is the estimate in our economic models of how much more production you're going to get. It's that big curve on top. And so what we projected was something on the order of 300 or 400 million barrels more. And that's almost exactly what they've gotten if you subtract out their, the chalk reservoir was weakened by the injection of seawater, and they had a little bit of subsidence. But of course, if you're on a platform, you know exactly how much subsidence that is because you watch the water come closer. And so, yeah, we could compensate for that and say that's going to squeeze a little more oil out. But the additional production, and they're now approaching 50% EUR.
Wow.
Yeah.
Wow.
And that is pretty much matches our lab results. And what I would tell them is, if you could take the water a little fresher, you would actually get even more out of Ekofisk. And that's a discussion we've had with the Danes. You know, right now, that particular field shifted ownership, and so our discussions didn't really count for much. But it shows you the potential, and it shows you that the potential isn't just some theory in the lab. It actually translates into real world dollars and extra production at a very low price. So we look at our economic models and we think, depending on scale, it's someplace on the order of $1 or $2 a barrel for each incremental barrel. And
That's
so I think,
amazing. That's amazing.
yeah, and I think most people can afford that. And I think particularly for small operators, it's even more important because you don't have much cash flow. You can't afford chemical or CO2. I mean, that's just way too expensive to get the rest, get more out of it.
Even, I mean, like I remember having just even hot oil treatment. So the wells that we had, even that was expensive. And you sit there going, okay, you know, does it,
yeah,
what's the payout? What's the ROI on that? And you have to be really, really careful.
And so, you know, we looked at that, and when we were pricing our services, it all came down to what you said. What do people spend on wells? What are they willing to spend? You know, what's a workover cost? What's a hot oil treatment cost? What's your particular problem, of course? That's one thing. So we priced ourselves to be someplace on the order of $50,000 a well. By the time everything's said and done, you paid us, you bought the water, you've injected it in there, the whole works. And of course, as you scale up, that price comes down.
Well, and the other thing too that brings to mind, I mean, I was thinking of, you know, obviously paraffin. Well, paraffin happens because of phase changes. And it sounds like with this, it's almost like a paraffin treat or an anti-paraffin treatment too, because you'll get the flow and you'll start reducing the conditions that cause paraffin anyway.
yeah, that's the exciting part of this. We've speculated about that inside the company, and that's why we're so excited to take it out there on the road
Yeah.
and find out, that people like yourself have brought this sort of thing up about paraffin, and we're like, I don't know. I want to go out and try it and find out, because
Right.
it might have a whole nother set of potential benefits. And I want to point out to people, it's not just salinity going down, which you see here in these graphs, but in the last several months, we've been working with some clients, and they actually need their salinity to go up. And so
interesting.
it is because, when I said to the client, I said, well, you need to come up, this is the Permian Basin. I said, you need to come up to about 250,000 TDS. And he goes, that's disposal water. And I said, wait a minute, are you saying you're going to get paid to improve the field? And he said, ooh. So,
That's nice. That's great.
he's looking into that possibility. So one man's trash is another man's treasure.
That's right. That's amazing to think that, especially, I mean, obviously you have to do a suitability study, you have to do the lab work to see, but in some cases, you're right. Instead of having to, you could take somebody's disposal.
Yeah, and so economically, it's free.
You get paid twice.
In essence, yeah. And that's what we've really focused on is we have a screening tool so that we can kind of tell you ahead of time. That's an almost free service. The lab work is fairly fast and inexpensive, much less expensive than typical wettability measurements. And then implementation, we support you all the way through and grant you a license to use it. And so that's where it worked out to be about 50K a well on a standard 10 to 20 well field. So total cost all the way through the project. And I've always said, and I will say now here on APG, if you want me to do this, I'll do it for free if you give me 10% of the back end. And I'll only take it if it works. And no one can me up on that. But
that's nice.
Yeah,
well, and so if somebody wants to get in touch with you, how do they do it?
We are at www.esalinity, all one word.com. That's our website. You can leave a message there, or I am Thyne at esalinity.com. So you can contact me directly, talk about this. I have endless slides, and I'm a geek, so love to talk to other geeks. But I like to talk to business people too.
Well, what I really like about this too is that in our science and technology showcase, we're really interested in showing how that type of thinking, the creative thinking and the willingness to challenge assumptions can lead to real solutions. And there's no reason at all to be discouraged.
It's hard to keep our heads up in this situation. But what I would just tell everybody is, look, we've been through this before. We're not quitters. Every one of us has had ups and downs. This is the industry we're in. We're going back up again. And I hope that engineered salinity is going to be a way, and part of that new way, as you said, we're going to have to pivot. Things are changing globally. But you tell me that oil and gas is going away. I go to the protests where the people drove up in their Mercedes to protest fossil fuels. Guys, come on. We're going to be around for another generation or two. And we're going to keep delivering the energy people need.
Well, we're all in this together, and whether or not we use petrochemicals we use oil and gas for petrochemicals, and we use electricity for fuel, fine. But we're all in it together. The solutions have to be done together. We can't fragment at this moment. So I love your message.
Well, thank you, Susan, and thank you for the time today. I know I went a little over time, but I get enthusiastic. And
that's all good.
And I just want to, say to all my friends out there, I've just had a couple conversations with people that are laid off, and it's a little bit shocking. It's a little bit difficult. Of course it is.
Yes.
And then you throw COVID on top of all this. But, we've been through this before, and we'll be through it probably again if we live long enough. but we will recover. And my prediction, so I'll go on the line and say, I think prices will be back up to where they were within 6 months.
My goodness.
Yeah, I know. I'm an optimist.
Okay, I'm buying some futures.
There you go. But if you're looking for old fields to buy, this is a great time, right?
Right.
And so let's look at the positive. Let's accentuate the positive. And in the words of the immortal Anonymous, give me one, oh Lord, give me just one more boom. I promise to pick it up this time.
I like that. Anonymous bumper sticker. I remember those.
Yeah. Well, thank you,
Anyway,
Susan, for your time today. And to
thank
the
you.
whole audience who may see this, call us up, talk to us. It's free.
Thank you. Well, Jeff, I'm really excited. And everyone, just to recap, we've been talking to Geoffrey Thyne of E-Sal, E-Salinity, and we will be back with more AAPG science and technology showcases in the future. So thank you.
Thank you, Susan.
Bye.
Bye.